Countdown.
Tahniah. Secara langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Secara langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Good evening, teachers, parents, and all the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber bermula percuma, selamanya percuma. How are you doing today? I hope all of you are ready for today's lessons. Before we proceed, let's begin our session by reciting Kitab for Muslim. For the non-Muslim, may pray according to your own religion. Al-Fatiha. Amin. Let me introduce myself. My name is Cikgu Shahnon from Penang Metropolitan College, the moderator of the day. We at Pusat Tuisyen Academy YouTuber will provide you with free online classes. Let's take this opportunity to do your revision. So, are you ready? Let me introduce our teacher for today's lesson. We have teacher Tang from Selangor Metropolitan College. We are now live on Teacher Tang's channel. Please support her by clicking subscribe. The topic of today's lesson is Introduction to Organic Chemistry Part 3. Okay, now we are in Part 3, and together with us, we also have Cikgu Mawa, who is control host in charge, ensure the smoothness of our lesson on technical support. So before we begin, I have a few reminders to all of you. First, please pay attention to our lesson. Stop chatting and use the chat section wisely. Number 2, regarding certificate link, the link will be given at the end of our lesson. Please use EDD, MOE, MyGuru, and MyJawi account when you fill in your particulars. Make sure you fill in the form within the time limit, which is 30 minutes. Okay, especially for the students, I announced the passcode for IU credit. For your information, the passcode will be announced 3 times, at the beginning, in the middle, and at the end of the broadcast. Announcement for the first passcode is letter A and number 1. I repeat, letter A and number 1. So without further ado, Teacher Tang is welcome to present Introduction to Organic Chemistry Part 3.
Okay, so thank you, Cikgu Shannon. Wait. Thank you, Cikgu Shannon. So good afternoon to all the students. So I'm Teacher Tan from College Matriculasi Selangor. So I have 9 years of experience teaching chemistry. So these are the teachers who are with me in the chemistry pre-U team. So all of us are led by Cikgu Shannon, the moderator of the day. Okay, and then with me, we also with us, we also have Teacher Bibi Lau and the Cikgu Mawar. So Cikgu Mawar is the control host for today's class, and also we have Teacher Kon. So beside pre-U chemistry team, so we have the mathematics team led by Teacher In, and also the biology team led by Cikgu Faiza, and also the physics pre-U team led by Cikgu Rosmaya, and also the account and economics team led by Madam Fizi. So here comes to our lesson for the day. So today I'm going to cover the introductions of organic chemistry part 3, which focus on the reactions of organic compounds. So for reactions of organic compound, so basically for all the organic compounds, if they're involved in chemical reaction, when organic compound involved in chemical reactions, it will always involve bond breaking and also bond forming. So certain covalent bond must be broken, then only a new covalent bond can be formed. And the chemical bond breaking, we can call it as bond cleavage or fissions, bond fissions. Okay, so both of them referring to covalent bond breaking. So basically, there are two types of covalent bond breaking or covalent bond cleavage. So the first one is called homolytic cleavage. So homo means same. So for homolytic cleavage, basically occurs in non-polar bond, where the two atoms involved in the non-polar bond having similar electronegativity. Okay, like for example, this is non-polar bond because it is a bond between two same atom. Okay, so two same atoms, they have same electronegativity. Therefore, the covalent bond between them is non-polar bond. So usually non-polar bond will undergo homolytic cleavage, where this covalent bond will break symmetrically. Okay, so will break symmetrically, so leaving each atom with one unpaired electron. So what does it mean? So basically, so between bromine atom in bromine molecule, so both of them, they share a pair of electron. Okay, and these two atoms, they have same electronegativity. So during homolytic cleavage or homolytic bond breaking, this covalent bond will break symmetrically. So means that after bond breaking, each of these atoms will get one electron. Okay, will get one electron and this. So another one will be gotten by another atom. So this is what meant by covalent bond breaking symmetrically. Okay, so and the species form with unpaired electron. So the species that form with unpaired electron, we call this species with unpaired electron free radicals. Free radicals. So how do we use arrow to represent homolytic cleavage or symmetrical bond breaking? So usually we will use, okay, let me draw again. So usually we will use a half-headed arrow. Okay, so this is the covalent bond. So we will use a half-headed arrow like this to represent single electron movement. So to represent single electron movement. So like for example, this is covalent bond. After bond breaking, this bromine atom will get one. So how do we use arrow to represent the homolytic cleavage? So basically, from this electron, it will go to the side like this. Okay, so we are moving one electron, single electron, therefore we use half-headed arrow to represent movement of single electron. So another electron will go to this atom. So like this. Okay, so this is how we draw the arrow for homolytic cleavage. Okay, so we use single electron, half-headed arrow to represent the movement of single electron in homolytic cleavage or symmetrical covalent bond breaking. So not all the time we draw electrons like this. So most of the time we are going to draw in a bond like this. So you must know that one single covalent bond represents two electrons. And because since these two electrons are the same, therefore these two electrons will be exactly in between. because both of them similar electronegativity, so having the same pull or attractions toward this pair electron, therefore will be exactly between the two atoms. And then when bond breaking, homolytic cleavage, so each of these electron will go to each of the atom, like this, to give us the free radicals with unpaired electron. Okay, so this is homolytic cleavage, symmetrical bond breaking, so giving us free radicals, okay, occur in non-polar bond, where the two atoms having similar electronegativity. So this is the first type of covalent bond cleavage. So the second type of covalent bond cleavage, we call it as heterolytic cleavage. So heterolytic cleavage occurs in polar bond. Polar bond. So polar bond is basically where the covalent bond, the covalent bond, the share pair electrons in the covalent bond is unequally shared. Okay, so the covalent, the share pair electron will be closer to the atoms that is more electronegative. Okay, so since, okay, like for example in the HBr, so in the HBr, bromine is more electronegative than hydrogen. Therefore, the share pair electron is more to the bromine side. Is more to the bromine side. Okay, so this is what we call as unequal sharing of electron pair in the covalent bond. Okay, so both are closer to the bromine. Okay, so why is it closer to the bromine? Because bromine is more electronegative and it will pull electrons, the share pair electrons, more to itself. Okay, for a polar bond, it will usually undergo heterolytic cleavage, where during the bond breaking, the bond will break asymmetrically. So break asymmetrically, and both share pair electrons will be transferred to the more electronegative atom. For example, here between hydrogen and bromine, bromine is more electronegative. Therefore, when this covalent bond break, okay, so the two electrons will move to bromine. So will move to bromine. So move to bromine. So now we are moving two electrons. Therefore, I'm using full-headed arrow. So full-headed arrow refer to movement of two electrons. Okay, movement of two electrons, we use full-headed arrow to represent it. Okay, and then what we get at the end is cation and the anion. So why do we get cation and anion? It is because, so how to form this covalent bond? So to form this covalent bond, basically hydrogen will provide one electron. It will contribute one electron for sharing. And bromine also will provide one electron for sharing. But then in heterolytic cleavage, when the bond break, both electrons will be taken by the bromine. Since both electrons taken by the bromine, so bromine get the hydrogen's electron. Therefore, bromine become Br minus 1. Okay, Br minus 1, the anion, because it gets one electron from the hydrogen. And the hydrogen lost this electron, therefore it becomes positively charged, positive 1. Okay, so it becomes the cation, okay, after heterolytic cleavage. So again, so for heterolytic cleavage occur in the polar bond, where the two atoms having different electronegativity, therefore the share pair electrons are unequally shared. And then when the bond break heterolytically, so the both share pair electrons will go to the atom that is more electronegative. Okay, therefore we use full-headed arrow to represent the movement of the share pair electron. Both go to the atom that is more electronegative. And the more electronegative atom will become the anion, and the less electronegative atom will become the cation. So that is heterolytic cleavage. So now we move on to look at question number 1. So for question number 1, so determine where determine what type of cleavage involved in A. Okay, so determine what type of bond cleavage in A. So this is bond breaking. So now I want you to tell me, so this part is bond breaking. So I want you to tell me this part, when the bond break, the covalent bond break, it will break heterolytically or homolytically. So this is homolytic bond breaking. So is homolytic cleavage or heterolytic cleavage? So I give you 30 seconds. So write your answer. So tell me, this is heterolytic cleavage or homolytic cleavage? Okay, so this is homolytic cleavage or heterolytic cleavage, class? You can also look at the arrow. So this is half-headed arrow, right? So half-headed arrow. And then you can also look at the product. What product is this? So the product with unpaired electron is called free radical. So which type of cleavage will give us free radical? Any answer from the students, Cikgu Shannon?
Still no. Maybe
Okay.
because their line very slow.
Oh,
You know,
okay. Okay.
1 letter for 1 minute. So many letter, so many minutes. Yeah, we're still waiting.
Okay, so you see half-headed arrow during the bond breaking. Okay, so the arrow using the half-headed arrow to represent the bond breaking, and at the end you get free radical. So this is indicating that, okay, never mind, I tell them the answer. So this is indicating that this bond cleavage is homolytic cleavage. Okay, so whereby so this bond, okay, so basically carbon and hydrogen, their electronegativity almost similar, therefore possible for carbon hydrogen bond to break homolytically. Okay, so and to give us the free radical as the product. So basically, to know whether it's homolytic cleavage or heterolytic cleavage, you can also look at the product. So for homolytic cleavage, you will get free radicals. Heterolytic cleavage, you will get cation and also the anion. So question number 2. So determine what type of cleavage involved in B. So here B, okay, so B is referring to this bond. Okay, so what type of cleavage involved in B? So can you see that here they are using full-headed arrow? Okay, full-headed arrow. So full-headed arrow, remember, referring to movement of 2 electrons. So in this single covalent bond, also having 2 electrons, and these 2 electrons both go to bromine. So both go to bromine. So in other words, this bond must be a polar bond. Okay, and where the share pair electron must be more to fluorine. Okay, closer to fluorine. Okay, because after the bond breaking, both electron go to bromine. Sorry, not fluorine. Both go to bromine. Okay, so means that bromine must be more electronegative atom here. So can you tell madam? Okay, can you tell teacher? So B here is what type of cleavage? Homolytic cleavage or heterolytic cleavage? So again, I give you another 30 seconds.
30 seconds. Because maybe the line very slow. When you asking the question, they will get the question maybe 5 minutes after that.
Okay. But we cannot delay the time, so
Yeah.
yeah, I will tell you the answer. So this is heterolytic cleavage. Okay, sorry, heterolytic cleavage. Okay, so I told you already, heterolytic cleavage. So the bond must be a polar bond. And hydrogen and bromine, okay, bromine is more electronegative. So means that the covalent, the shared electron in this covalent bond is more towards bromine. So when more towards bromine, okay, so when the bond break, both electron is more likely to go to bromine. Okay, so the bond will break heterolytically. Okay, so and then we are expecting the product to be cation and the anion. Okay, because heterolytic cleavage. So now we move on to look at reactions intermediate. So what is reactions intermediate? So basically reactions intermediate is a species that is very reactive. Okay, it will form in between a reaction. So means that it is not a reactant, not a product, but it's a species that form in between reactant and product. Okay, so and that species is very reactive. Okay, so once it is been formed, then it will react very fast with another species in order to form product. Okay, so in your syllabus, usually we are going to look at 3 different types of intermediate. So the first intermediate is called free radical. So still remember what is free radical? So basically, free radical form after homolytic cleavage. Okay, it formed after homolytic cleavage. And how do we know that it is free radical? So free radical having unpaired electron. Okay, just like this, having unpaired electron. So they are free radicals. And these free radicals form after a homolytic cleavage. Okay, so this free radical, they are intermediate of a reaction and usually is very reactive. So they will tend to react with another species in a reaction very quickly to form products, okay, or byproducts. So the second reactions intermediate, we call it as carbocation. So what is carbocation? So carbo here referring to carbon. So cation means that positively charged. So basically, what is carbocation? So basically, it's referring to a species where having positively charged on carbon atom. Okay, so it is a species that form in a reaction, okay, in between a reaction, okay, where the carbon carry a positive charge. And usually carbocation will form in heterolytic cleavage. Okay, carbocation positively charged, so means that it is a type of cation. So it must be formed from heterolytic cleavage. Like for example, in this species here, okay, so can you see that this bond is a polar bond? Okay, chlorine is more electronegative than carbon. Therefore, this bond is a polar bond, and the share pair electron is closer to the chlorine. Okay, therefore, when this bond break, this covalent bond break, both electrons will tend to move to chlorine because chlorine is more electronegative. So since both electrons move to chlorine, chlorine will become chloride ion, and this carbon here will become positively charged. And this species that is the intermediate that form in between the reaction, this species with carbon carrying the positive charge, we call it as carbocation intermediate. So this is carbocation intermediate. So another intermediate is called carbanion. So carbanion, again, carb refer to carbon. This is anion. Anion, so negatively charged. So what is carbanion? So carbanion, again, is a very reactive intermediate, okay, that form in between the reaction. So where the carbon atom carrying a negative charge. So the carbon atom, okay, will carry the negative charge. And usually it will be formed in the heterolytic cleavage. Like for example, in this bond. So in this bond, so we know that this is lithium. Lithium is metal, so it is very electropositive. So electropositive means that will tend to give away the electron. So means that this again is a polar bond whereby the two electron, the share pair electron is more to carbon, because lithium electropositive. So in other words, carbon is more electronegative than lithium. Okay, so therefore this bond is a polar bond. So when polar bond break, okay, so the two electron will be transferred to the atom that is more electronegative, and here is the carbon, so giving us cation and also the anion. And for this anion having the carbon that carrying the negative charge, so therefore is called carbanion. Okay, carbanion. And this carbanion, so again, is a type of intermediate that form in between the reaction, and it's very reactive, so will react very quickly with another species to form product or byproducts. So now we move on to look at classifications of free radical. So how do we classify free radicals? So to classify free radicals, so first we need to look at the reference carbon. Okay, we must look at the reference carbon. So which one is the reference carbon? It's the carbon with the unpaired electron. So this carbon having the unpaired electron, so it is the reference carbon. So to classify the free radical, first we circle the reference carbon, then we need to look at how many alkyl group or carbon that is attached directly to this reference carbon. Like for example, in this species here, so the reference carbon that carry the unpaired electron having no alkyl group as the friends, no carbon as the friend. So if no carbon or alkyl group as a friends, then we call this as methyl radical. Okay, methyl radical. Okay, so how about the second species here? So circle the reference carbon. So can you see that this reference carbon with unpaired electron attached to one alkyl group? So attached to one alkyl group. So if attached to one alkyl group, this is primary free radical. Okay, so primary free radical. So then we move on to look at the the third species. Circle the reference carbon first, and then look at the alkyl group. So this carbon, the reference carbon with unpaired electron attached to two alkyl group. Therefore, this is secondary free radicals. Okay, and look at the last species here. So circle the reference carbon, okay, and then count how many alkyl group directly attached to this reference carbon. So 1, 2, 3. So 3, so this is tertiary free radical. Okay, so this is tertiary free radical. So this is how we classify
Teacher
free
Tang,
radical. Yeah.
Teacher Tang,
Yeah.
I think better we stop for a while for advertisement.
Oh, okay.
Okay.
Okay, sure.
Okay. Before that, I will announce the next passcode. The passcode is number 6 and number 8. I repeat, number 6 and number 8. So, ladies and gentlemen, we uh, we go to advertisement. Cikgu Mawar.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, student, welcome back. Let's continue our lesson with Teacher Tang.
Okay. Thank you, Cikgu Shannon. Okay, so we move on to look at relative stability of free radicals. So for free radicals, you must know that free radicals is electron deficient. So electron deficient means that not enough electrons, okay, or we can call it as electron poor. So why is it electron poor? It is because if we look at around the carbon in the free radical, only having 7 electrons. So only having 7 electrons, so means that free radical is electron poor or electron deficient. So when it is electron deficient, so means that it is not very stable, So how can it be stabilized? So it can be stabilized by alkyl group. So alkyl group having a property called electron donating property. Okay, so called electron donating property. So means that alkyl group tend to release electron to the neighbor, Okay, so free radical is electron deficient, electron poor. Alkyl group want to release electron to the carbon that having the unpaired electron. Okay, having the unpaired electron. So because of this, so more alkyl group around the carbon with unpaired electron, more stable will be the free radical. So I told you already why free radical is electron poor. It is because at the carbon that having the unpaired electron not yet attached, so it is electron poor. Okay, so if it is attached to more alkyl group, then it will be more stable. Okay, so for methyl radical, there is no alkyl group attached to it, so we will expect methyl radical to be the least stable. Okay, then for primary free radical, can you see that the carbon with unpaired electron is attached to one alkyl group, and this alkyl group tend to release electron to the carbon with unpaired electron to stabilize the carbon with unpaired electron. Okay, therefore primary free radical is more stable than methyl radical. Then we move on to the secondary free radical. So this free radical having 2 alkyl group, so means that it will be more stable compared to primary free radical. Okay, because 2 alkyl group stabilize the carbon with unpaired electron. in secondary free radical. Then we move on to look at the tertiary free radical. So having
OK， 你去你跟狗狗讲，狗狗给你，叫狗狗给你。
Okay, sorry about that. Okay, so for tertiary free radical, okay, so the carbon with the unpaired electron is attached to 3 alkyl group. So means that there are 3 alkyl group stabilize the carbon with the unpaired electron. Therefore, among these methyl radical, primary free radical, secondary free radical, and tertiary free radical is the most stable. Why most stable? Because the carbon with unpaired electron attached to the most number of alkyl group in order to stabilize the carbon with unpaired electron, which is electron deficient. Okay, so I summarize it here. So the stability of free radical increases with the number of alkyl group present. So more number of alkyl group around the carbon with unpaired electron, the free radical will have greater stability. Okay, so basically the alkyl group having the electron donating property able to stabilize the carbon with the unpaired electron in the free radical. Then we move on to look at the second type of intermediate, carbocation ion. So how do we classify carbocation ion? So to stabilize, okay, so how to classify carbocation ion? So also the same. So we circle the reference carbon. So which one is the reference carbon? Is the carbon that carry the positive charge. Okay, so for methyl carbocation ion, can you see that this reference carbon attached to no alkyl group? So if attached to no alkyl group, then we call it as methyl carbocation ion. Okay, so now we circle this reference carbon with the positive charge. Can you see that it is attached to one alkyl group? So if attached to one alkyl group, then this is called primary carbocation ion. Then we move on to look at another species. Again, we circle the reference carbon. So it's the carbon that carry the positive charge. And it is this carbon, reference carbon, attached to 2 alkyl group. So therefore, this species is secondary carbocation ion. And the last species here, so again, circle the carbon that carry the positive charge. It is attached to 3 alkyl group. So therefore, this is tertiary carbocation ion. So now we move on to look at relative stability of carbocation ion. Okay, again, carbocation ion, if we look at the carbon that carry the positive charge, around it only having 6 electrons. So again, carbocation ion is electron deficient, means that electron poor, not enough electron around it. Okay, so if not enough electron around it, then it will require alkyl group to stabilize it, because alkyl group, remember, it is the electron donating group, tend to release electron to the carbon that is positively charged. Okay, so now we look at methyl carbocation ion. So for methyl carbocation ion, there is no alkyl group attached to the carbon that carry the positive charge. Therefore, methyl carbocation ion is the least stable. Then we move on to look at the primary carbocation ion. It has 1 alkyl group attached to it. So therefore, it is more stable compared to methyl carbocation ion. Then for the secondary carbocation ion attached to 2 alkyl group, so means that having 2 alkyl group to stabilize it. So therefore, secondary carbocation ion is more stable than the primary carbocation ion. Then we move on to look at tertiary carbocation ion. So why is this tertiary carbocation ion? Because the carbon carry the positive charge attached to 3 alkyl group. So 3 alkyl group release electron to the carbon that carry the positive charge. Therefore, tertiary carbocation ion is the most stable. Okay, so I summarize it here. So carbocation ion, electron deficient. Okay, therefore, its stability increases with increase of number of alkyl group that attach directly to the carbon that carry the positive charge. Okay, so more number of alkyl group around the carbon that carry the positive charge, more stable is the carbocation ion. Okay, so alkyl group can stabilize the carbon that carry the positive charge. So can stabilize the carbocation ion. Then now we move on to look at carbanions. Okay, so for carbanions, so how to classify it? So again, we need to circle the reference carbon. So the reference carbon is the carbon that carry the negative charge. So for methyl carbanion, no alkyl group attached to it. For primary carbanion, so the reference carbon is the carbon that carry the negative charge. So having one alkyl group directly attached to it. Okay, so for secondary carbanion, so having two alkyl group directly attached to the carbon that carry the negative charge. For tertiary carbanion, there are three alkyl group directly attached to the carbon that carry the negative charge. So for carbanion, so it is negatively charged, so means that it is electron rich. Carbanion, electron rich. So if electron rich, then it doesn't need alkyl group to release electrons to it because it is already very rich in electron. So doesn't need the alkyl group to release electrons to it. Okay, so the more alkyl group release electrons to it, somehow actually will destabilize the carbanion because it is already very rich in electron. So alkyl group want to give electrons to it some more, so making it more unstable. Okay, more unstable. So carbanion, so basically stability of carbanion decreases with the number of alkyl group present. So methyl carbanion, no alkyl group attached to it, therefore it is the most stable. For primary carbanion, having one alkyl group attached to it, so it is already very rich in electron. Alkyl group want to give some more electrons to it, so making it less stable. So therefore, primary carbanion is less stable compared to methyl carbanion. So for secondary carbanion, okay, two alkyl group give electron to the carbon that carry the negative charge, so making the secondary carbanion even less stable compared to the primary. And the least stable will be the tertiary carbanion ion. Okay, carbanion. Okay, because so the carbon carry the negative charge, having three alkyl group releasing electrons to it. It is already very rich in electron, so three alkyl group want to give some more electrons to it, so making the tertiary carbanion the least stable. Okay, so for carbanion, so greater the number of alkyl group around the carbon that carry the negative charge, the least stable is the carbanion. Okay, so alkyl group is the electron donating group. It will destabilize the negatively charged carbon of the carbanion. So okay, so to summarize, so carbocation ion and free radical electron deficient, so they like alkyl group. Okay, but for carbanion, electron rich, so doesn't like alkyl group. Okay, so now we move on to look at question number 3. So which of the following is the most stable carbocation ion? Okay, so which of the following is the most stable carbocation ion? So in order to know which one is the most stable, actually you need to know the class of the carbocation ion first. You need to know the class of the carbocation ion first. So to know the class of the carbocation ion, remember first you need to circle the reference carbon that carry the positive charge. Like for example, A, this is the reference carbon. So this is the reference carbon attached to 1, 2, 3 alkyl group attached to 3 alkyl group. So therefore, this is tertiary carbocation ion. Okay, so for B, okay, must remember circle the reference carbon first. Okay, attached to 1 alkyl group. So this is primary carbocation ion. So C, so this is the reference carbon attached to no alkyl group. All are hydrogen. So no alkyl group. So this is methyl cation, okay, or methyl carbocation ion. Okay, so and D, so circle the reference carbon. So 2 hydrogen, so means that 1 alkyl group. So only 1 alkyl group. So this is primary carbocation ion. So remember, carbocation ion is electron deficient. So attached to more carbocation ion, more stable is the carbocation ion. So what is the answer for this question, class? I'm already giving you a lot of hints. So any question, any answer given by the students? So I give you 30 seconds.
30
Okay.
seconds.
Yeah, 30 seconds to answer this question. Any answer from the student?
Not yet.
Oh, not yet.
Eng Chia Ying? Or maybe Eng Chia Ying want to answer? Okay. So any answer yet? Not yet.
Okay.
They are quite basic. Yeah, okay. We have answer from Z Chin Chai. C.
Okay. Carbocation ion, electron deficient or electron poor. So if electron poor, 1 more alkyl group to stabilize it.
Eng
Okay.
Chia Ying also C.
Okay, to stabilize it. Okay, so if methyl, no alkyl group, all are hydrogen, no alkyl group. So means that methyl carbocation ion is the least stable. We want the most stable. So answer is not C because methyl having no alkyl group, so means that methyl cation is the least stable. Okay, so if primary carbocation ion only having 1 alkyl group, so this one also having 1, but tertiary having 3, so therefore answer should be A. Okay, answer should be A. Remember, carbocation ion electron poor, 1 more alkyl group to stabilize it. Okay, so the answer is A. It's okay. We can try question number 4.
Teacher Tang,
Yeah?
maybe they read it as a most unstable carbocation ion.
Oh, most unstable. Okay, we want most stable. Okay, we want
maybe I don't know. Okay, proceed for the next question.
Okay, good. So which one is the most stable, not unstable, most stable free radical? So for B, the unpaired electron is not here, it's here. It's on this carbon. Okay, so again, want to find which one is the most stable free radical. Again, free radical is electron poor or electron deficient. So in order to stabilize it, 1 more alkyl group attached to the reference carbon. Okay, so to know which one more stable, remember we must circle the reference carbon first. and then C, how many alkyl group attached to it. Like for example, this carbon attached to 2 hydrogen, so means that 1 alkyl group. So 1 alkyl group, so this is 1 alkyl group, so this is primary free radical. Okay, so for this carbon having 1 hydrogen means that having 2 alkyl group. So 2 alkyl group attached to it, so this is secondary free radical. And for C, this is the reference carbon. All are hydrogen attached to it, so this is methyl radical. And for D, this is the reference carbon, so no hydrogen directly attached to it, so means that it has 1, 2, 3 alkyl group. So 3 alkyl group, so this is tertiary free radical. So again, free radical, electron poor, 1 more alkyl group to stabilize it. So which one is the answer? A, B, C, D? Which one is the answer for question number 4?
Okay, student, you can answer question number 4.
So I give you 30 seconds.
Same trends like free radical, you know.
Yeah, same like the carbocation.
Oh, this one is free radical.
Yeah, just now
Same
carbocation.
trends like carbocation.
So what's your answer, student? 10 more seconds.
Still waiting.
No answer?
Maybe because of line, as I said.
Oh, yeah. Okay. It's okay.
Maybe it will take 5 minutes for them.
Okay, so we cannot wait. So
We
I
have
give
we have an answer now from
okay.
Chia Ying. Chia Ying, the answer is D.
Very good. The answer is D. Okay, the answer
Not
is D.
Chia
Very good.
Yao. Chia Yao, I think that's the answer. Question 3. Question 3.
Oh, okay. Yeah.
Chia Ying, Z Chin Chai. The answer is D.
Okay, very good. D. Okay, so remember, free radical and carbocation, they are electron poor. So 1 more alkyl group to stabilize the carbocation and also free radical. So now I move on to look at electrophiles and nucleophile. So what is electrophile? So electrophile is electron deficient species, means that electrophile is electron poor species. Okay, electron poor species. So example, what are the electron poor species? So those with positive charge. Those with positive charge, they are electron deficient or electron poor species. So therefore, they are electrophile. Like carbocation, electron poor because having the positive charge. So it is electrophile. Okay, so beside that, we have Lewis acid. So remember, Lewis acid having incomplete octet. Remember, like for example, AlCl3, Al here having incomplete octet, only having 6 electrons surrounding, Fe and also boron, okay, in AlCl3, FeCl3, Bf3. So they are incomplete octet. So if incomplete octet means that they have empty orbital. So, or in other words, they are electron poor. They have incomplete octet. Not enough electron to achieve octet. So therefore, they are electron poor species, or we call it as electrophile. Okay, so oxidizing agent like chlorine, bromine, iodine, they are usually electrophile as well. Okay, so what is electrophilic site? Okay, So must not confuse yourself with electrophile and electrophilic site. Electrophilic site refer to the carbon that is having low electron density. Like for example, carbon attached to halogen. So when carbon attached to halogen, halogen is electronegative. This carbon is less electronegative, so it will be partially positively charged, and therefore this carbon, this side, the carbon, we call it as electrophilic site. Okay, tempat yang mempunyai low electron density, we call it as electrophilic site. Okay, so beside that, like carbon attached to oxygen. Okay, so carbon attached to oxygen. This carbon here is also electrophilic site. Why? Because oxygen very electronegative, so it will be partially negatively charged. But this carbon, because attached to oxygen, which is very electronegative, therefore it will be partially positively charged. Okay, okay, so partially positive charge, therefore it is electrophilic site. Okay, electrophilic site, tempat yang mempunyai lower electron density. Okay, so now we move on to look at nucleophile. Nucleophile rich in electron, species that is rich in electron. So how to know it is rich in electron? So it is negatively charged. So negatively charged, so rich in electron. Okay, it will be nucleophile. Okay, so beside that, so Lewis base, so they have lone pair. So they have lone pair. So Lewis base, usually they have lone pair. So therefore, they are rich in electron. So they are nucleophile. So reducing agent like chloride, bromide, and iodide, so they are also nucleophile because rich in electron. Okay, so those with lone pair, okay, so those with lone pair, usually rich in electron, so will be nucleophile. Okay, not to confuse with nucleophilic site. So nucleophilic site is tempat that have high electron density. Like for example, in carbon-carbon double bond. So in carbon-carbon double bond, here is high electron density region. Okay, why? Because it has 1, 2, 3, 4 electron, okay, between the two carbon. So 4 electron between two carbon. So 2 are pi electrons and another 2 involved in the sigma bond. So having the pi electron, so causes this side to be electrophilic site where it has high density of electron. So beside that, like in benzene ring, so also it is nucleophilic site, okay, having high electron density because having a lot of pi electrons. Okay, so then now we can move on to look at types of organic reaction. So we have addition, elimination, substitutions, and rearrangement. Okay, we look at additions first. So for addition, basically, so if you see like multiple bond become single bond. Okay, so like double bond become single bond, then it will be addition type of reaction. Okay, because additions reaction usually involve breaking one of the pi bond to form single bond or sigma bond. Okay, like for example, this one. Okay, so this is, remember, carbon-carbon double bond is nucleophilic site. So electron rich. So electron rich will be attacked by electrophile. Okay, and then after attack by electrophile, it will become all single bond. So all single bond, therefore addition. Because attacked by electrophile, therefore it is being called as electrophilic addition. I should draw this. Attacked by electrophile, therefore it is electrophilic addition. Okay, so another type is nucleophilic addition, because can you see carbon double bond to the oxygen here becomes single bond, become two single bond. So this is addition type of reaction. So remember this carbon here attached to oxygen. So attached to oxygen, therefore it is electrophilic site. Okay, electron poor. So when it is electron poor, it will be attacked by nucleophile. When it is attacked by nucleophile, therefore it is being called as nucleophilic additions type of reaction. So now we move on to look at elimination. So elimination, basically from single bond, it will form multiple bond. Okay, like for example, inside here, all single bond. Okay, after elimination, eliminate small molecule, then form double bond, form multiple bond, double bond. So this type of reaction, we call it as elimination. So another type of reaction is called substitution. So for substitution, there will be no change in degree of saturation. Means that if all single bond, at the end, the product all will be single bond. Only one atom or a group of atoms will be replaced by another atom or another group of atoms. Okay, so example, in free radical substitution, so free radical substitutions always occur in alkane. Okay, so one of the hydrogen of the alkane will be replaced by halogen in free radical substitutions reaction of alkane. Okay, so like for example, electrophilic substitution. So this hydrogen replaced by bromine. The degree of saturation is still the same, but hydrogen replaced by bromine. Okay, why is it electrophilic substitution? It is because, remember, benzene ring, okay, I told you just now, this is electron rich. So electron rich, therefore attack electrophile. So attack electrophile, therefore it is called electrophilic substitution, because bromine replace hydrogen. That's why substitution. So another one is nucleophilic substitution. So you can see that bromine here is replaced by OH. Bromine here is replaced by OH. And for this carbon, it is electron deficient or electron poor. Therefore, will be attacked by nucleophile, Okay, so since it is attacked by nucleophile, therefore it's nucleophilic. And when nucleophile come in, replace the Br, therefore it's called nucleophilic substitution. So the last one is rearrangement. So for rearrangement, the atoms and bond change position. They change position. So basically, the reagent reorganizes the bond and the atom. Like for example, here, okay, we have carbon-carbon double bond and the OH. So rearrange, here becomes single bond, and the double bond move between carbon and oxygen. So this is rearrangement type of reaction. Okay, so another one, so the OH, can you see that at first it is attached to this carbon, rearrange, it attached to this carbon. Okay, it changed positions with one of the hydrogen. Okay, so this type of reaction, we call it as rearrangement. Okay, I think already the time. So you can try the question number 5 yourself. Okay, so basically that's it from me today. So I pass to Cikgu Shannon.
Alhamdulillah, we are done with today's lesson. We have learned a lot from teacher Tang's, until more than 1 hour actually. All right. Congratulations to those who are able to follow our session from the beginning till the end. And thank you very much, Teacher Tang, for such an interesting lesson. Now it's time for me to announce the last passcode. The passcode is
Students, please wait for a while. We have the... Okay, so Cikgu Shannon is back.
okay, right. Now it's time for me to announce the last passcode. The passcode is number 5 and number 6. I repeat, number 5 and number 6, and the presenter telegram is t.me/Tang Iyun. Okay, and now I think that's all for now. See you in another lesson. Please do remember, stay at home and study. Study. Goodbye, everyone. Have a nice weekend. Bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.